In this video, we're going to talk about the relationship between heat and work. Before we do that, we need to define two parts, a system versus the surroundings. The system is what we're explaining for change, okay? And so it can be a solution, or it can actually just be, a lot of times we look at just the compounds itself, and the solution or the water surrounding it becomes part of the surroundings also. And then the surroundings is everything around the system that we're interested in the environment. So, but a lot of times when we do measurements, we measure the actual surroundings or the solution and looking at the actual compounds themselves. Work is energy transferred in or out of a thermodynamic system to equate to moving an object through force of field. When the work is done on the system, it's positive. So in this example, pushing the blocks up the hill, work is a positive number. When work is done by the system, work is negative. And so here's an example of work done on by the system. Okay, and so that's the weight. I'm sorry, the piston is expanding, which pulls this out, and now it's going to be going in. Okay, or work done on a system. So in this example, it's positive. In this example, it's negative. The weight's going to pull the piston back down. Okay. Heat is energy that flows in and out due to temperature. So a lot of times temperature and heat are confused for each other. Temperature is a measurement. Heat is a unit of energy. Okay. Heat always flows from hot to cold until it's equal temperature, thermal equilibrium. If heat is added, Q is positive. If heat is given off, Q is negative. So this diagram shows the fact that the heat's going to always flow from hot to the cold area until both sides are equal temperature, which is the thermal equilibrium. Intensive versus extensive. Extensive depends on the amount of material, so that's going to be something like mass, volume, that type of thing. Intensive is independent of the amount of material. So intensive properties are boiling points. It doesn't matter if I have an ounce of water or if I have a gallon of water, it boils at the same temperature. Color doesn't matter how much is there. Temperature does not matter how much is there. Hardness doesn't matter how much is there. Density is another one of these, okay, that doesn't matter how much is there. Volume and mass, however, do. The size, which is directly usually related to one of those two. The weight is the same thing as mass, except with the gravitational force, and length. So basically, you can see all these either have to me, all relate back to either the mass or the volume of them. Okay. And a state function is the last definition that we're going to do for this section, and it's that it depends only on its present state and its final state, not the way in which it gets there. So this picture is from the textbook, and campsite A is at 1,200 feet, campsite B is at 4,800 feet. So if you're a rock climber, you can go straight up the side here, and it's a much shorter distance to get there. If you are a hiker, you can do the switchback trails back and forth, and so the incline is much shorter or much less steep. Okay, it's a much longer distance, but for a state function, whether I take the long switchback trails or the short rock climbing trails, it doesn't matter. The change in altitude from 4,800 feet to 1,200 feet is the same, and so that would make the altitude the state function. And that is the end of this video.